Wi-Fi Analyzer. A Wi-Fi analyzer is a diagnostic tool available as a dedicated hardware device or a software application used to measure, record, and visualize the invisible radio frequencies of a wireless local area network. When you're troubleshooting a slow wireless connection in a business environment or optimizing the network for an Ubuntu Home Lab, you cannot rely on the basic 4-bar Wi-Fi icon on your taskbar. That icon only tells you that a signal exists. A Wi-Fi analyzer cracks open the 802.11 protocol and reveals the raw data behind the connection, allowing an IT professional to diagnose congestion, eliminate dead zones, and secure the airspace. The primary metric, signal strength in dBm. The most fundamental purpose of a Wi-Fi analyzer is to provide a mathematically precise measurement of signal strength. It measures this using a unit called dBm, or decibel milliwatts. Because wireless signals degrade incredibly fast as they travel through the air and penetrate solid objects, this measurement is always represented as a negative number. When you look at the interface of a Wi-Fi analyzer, you must understand how to read these negative integers. Negative 30 dBm is a perfect, extremely powerful connection. You are likely standing right next to the wireless access point. Negative 65 dBm is the industry standard for a reliable, fast connection that can easily handle high-definition streaming and voice-over IP calls. Negative 80 dBm is a severely degraded connection. At this level, data packets are dropping, and the device is struggling to maintain its link to the network. By tracking these exact numbers, a technician can walk through a building and physically locate the source of a connection problem, proving mathematically whether the issue is a failing router or simply a thick brick wall blocking the radio waves. Diagnosing congestion, channel overlap. The second major purpose of this tool is mapping the frequency spectrum to find interference. This is a critical troubleshooting skill for your CompTIA A+ exam. In the 2.4 GHz band, the radio spectrum is divided into 14 distinct channels. However, these channels are very narrow, meaning they bleed into one another. If your router is broadcasting on channel 3 and your neighbor's router is broadcasting on channel 4, the two radio signals will crash into each other in the air, causing co-channel interference. This forces both routers to constantly retransmit lost data, slowing both networks to a crawl. When you open a Wi-Fi analyzer, it generates a graph showing exactly which channels every router in the vicinity is using. In the United States, there are only 3 channels in the 2.4 band that do not overlap with each other: Channel 1, Channel 6, and Channel 11. By using the analyzer to scan the environment, you can quickly identify which of these 3 channels is the least crowded and manually reconfigure your access point to use that specific frequency, instantly curing the congestion issue. Visualizing the environment, the heat map. In an enterprise environment spanning an entire office floor, technicians use an advanced feature of Wi-Fi analyzers called heat mapping. To create a heat map, the administrator loads a digital floor plan of the building into the software. They then walk the entire physical footprint of the office with a laptop or a specialized tablet. The analyzer continuously records the dBm signal strength and pairs it with the physical location on the map. The resulting image uses a color gradient, usually bright red for strong signals and dark blue for weak signals, to visually represent the wireless coverage. This allows the network architect to precisely identify dead zones where the signal fails to reach, dictating exactly where they need to run new copper cables to mount additional access points. The cybersecurity application, Rogue Access Points. For anyone pursuing ethical hacking and penetration testing, the Wi-Fi analyzer is a mandatory reconnaissance tool. You cannot secure a network if you do not know what is broadcasting inside your perimeter. In a corporate environment, a severe security breach occurs when an employee sneaks a cheap wireless router from home and plugs it directly into the secure, wired corporate wall jack. This is known as a rogue access point. It completely bypasses the corporate firewall, broadcasting the secure internal network directly into the parking lot without any encryption. Security professionals use Wi-Fi analyzers to actively sweep the airspace for these unauthorized broadcasts. Because the analyzer reveals the MAC address and the hardware manufacturer of every broadcasting antenna, the security team can instantly spot a consumer-grade router sitting in a sea of enterprise hardware and physically track it down before an attacker can exploit it. Furthermore, it is the primary tool us ED to detect evil twins, malicious hotspots set up by attackers to mimic the legitimate network and steal employee credentials. By mastering the Wi-Fi analyzer, you move past guessing games and gain the ability to physically see and manipulate the invisible architecture of your wireless environment.